So continue our discussion. The molar conductivity is equal to the electrical conductivity over the concentration, right? So because of the ion-ion and ion-solvent interaction, this value is not constant, so it varies with concentration. Specifically, this value lowers with concentration. Now, Kohlrausch Law for strong electrolyte, right, found that the molar conductivity of electrolyte at a given concentration is equal to the molar conductivity at infinite dilution minus a constant times the function of the concentration. This here is C over C naught. C naught is just a standard concentration, which is 1. Now, inside this K, this constant, this is K, and this is kappa, right? Please know the difference. K here, the constant, is a collection of other constants which describe the ion-ion interaction and ion-solvent interaction. Okay, you're familiar with this graph in the lecture. So one effect is because the when the electric potential is applied, the sphere that we discussed, the Debye-Huckel sphere or the diffuse ion sphere surrounding the central ions, will be disturbed, and it will form this X shape instead of unsymmetric X shape instead of the symmetric sphere shape. Now, when you have this unsymmetric shape, because of the negative ion moving in this direction, this part will be more negative and this part will be positive, and this creates an attraction to the negative part, negative ion moving in this direction, that slows down the movement of the ions. Okay. And second, there is an electrophoretic effect. Please read that in the book, or read it in the slide. And there is the viscosity of the solvent that creates the resistance of the moving ion. Look at the Kohlrausch Law for strong electrolyte that give the correlation between concentration and molar conductivity. So in an experiment, when you're measuring the electrical conductivity, this is what you will get. You will measure kappa, and then you will have to divide that with the concentration of that electrolyte, and you will get a molar conductivity. And then if you do that for different concentrations, right, you plot the x-axis to be square root of concentration. You will make data 1, data 3, 4, and you will make a plot. And this plot will give you a straight line, right? So this straight line should follow, or will follow, Kohlrausch Law, and the intercept would be the molar conductivity at infinite dilution. This is the molar conductivity when the concentration is reaching 0. So it's almost impossible to do this experimentally, and you can get this value by doing an extrapolation of this following Kohlrausch Law.